Hello everyone, myself Miss Priyanka Shahane and I am currently working as an assistant professor at SCDR's Pune Institute of Computer Technology. In this video, we are going to study how to implement support vector machine using Sklearn library of Python. This is my short introduction. Let us see what is support vector machine or SVM. The goal of support vector machine algorithm is to create the baseline or decision boundary that can segregate n-dimensional space into classes so that it can easily put the new data point in the correct category in future. The best decision boundary is called as hyperplane. SVM chooses extreme points or vectors that help in creating hyperplane. These extreme cases are called as support vectors and hence the algorithm is termed as support vector machine. This is the diagram of support vector machine or SVM. In this diagram, this is n-dimensional space and this n-dimensional space has positive class members which are indicated by blue color and negative class members which are indicated by green color. Here we have positive hyperplane which segregates the members of positive class from the members of negative class, and negative hyperplane which segregates the members of negative class from members of positive class. Here we have constructed maximum margin hyperplane based on positive hyperplane and negative hyperplane. Therefore, these two hyperplanes are known as support vectors and this machine is known as support vector machine. Now, let us see how to implement support vector machine programmatically using Sklearn library of Python. Here we have considered the problem statement. Classification of tumor as benign means non-cancerous or malignant means cancerous using support vector machine or SVM. Our first line of code is from Sklearn import datasets. For applying our support vector machine algorithm, we will need some dataset. Sklearn library of machine learning provides some inbuilt datasets. So here we are going to use dataset from Sklearn library. For that, we have created one variable named as cancer to store our dataset and loaded the dataset named as breast cancer from datasets package that we have imported in previous line of code. Our dataset had some features and target class labels corresponding to the values of those features. In order to display the names of these features, datasets package of Sklearn library provides function named as feature_names. To write this function, we follow the format object.its method. Therefore, here we have written cancer.feature_names. Why cancer? Because if you remember, in the previous line of code, we have loaded our breast cancer dataset to the variable named as cancer. To display the output of these feature names to end user, we have written it inside print function. And here you can see the output written by this function. We all know that cancer is nothing but a tumor. So that tumor has different features like mean radius, mean texture, mean perimeter, mean area and so on, and based on all these features we can predict whether the given tumor is malignant means cancerous or it is benign means non-cancerous. In the same way, in order to display the target names means output classes, dataset package of Sklearn library has function named as target_names. And here also we follow the format object.its method. Therefore, we have written cancer.target_names. Here we have written cancer because we have stored our dataset inside variable named as cancer in the previous line of code. In order to display output of this operation to end user, we have written it inside print function. And here we can see the output of second line. It is malignant and benign. To display shape of our dataset, we have data.shape function under datasets package of scikit-learn library. This function returns number of rows and columns in our dataset. So, in our cancer dataset, we have 569 rows which corresponds to number of records and 30 columns which corresponds to number of features. To display the values of our target class to end user, we have target function under datasets package of scikit-learn library, and it follows the syntax object.its method. Therefore, here we have written cancer.target, and in order to display the output of this operation to end user, we have written it inside print function, and you can see it has returned the values of target class for all the records in our dataset. These output values are zeros and ones. 0 corresponds to malignant and 1 corresponds to benign. We all know that support vector machine is a supervised learning algorithm, and in case of supervised learning, we need to split our class level data into two parts, that is training data and testing data, and this can be done with the help of train test split package of Sklearn model selection library. For splitting our dataset, we need to create four variables: xtrain, xtest, ytrain and ytest. Here xtrain will contain features of training dataset, xtest will contain features of testing dataset, ytrain will contain output class labels corresponding to the features in xtrain dataset, and ytest will contain output class labels corresponding to the features in xtest dataset. Here we have function named as train_test_split for splitting our dataset into two parts. The first parameter passed to our train test split function is cancer.data. It refers to the values of features in our breast cancer dataset. Second parameter passed is cancer.target. It refers to the values of output classes corresponding to the features in our breast cancer dataset. Third parameter is test_size. Here we have specified test size is equal to 0.3. It means 30% records will go for testing and remaining 70% records will go for training. If we specify test size is equal to 0.2, then 20% records will go for testing and remaining 80% records will go for training. Then fourth parameter is random state. This random state parameter is required for shuffling the records in our dataset while training and testing. Now we are going to apply support vector machine algorithm on our data. For that, we have imported SVM package from scikit-learn library of Python. First of all, we will train our SVM algorithm using training data, and then we will check the accuracy of trained SVM model using testing data. SVM package of scikit-learn library consists of function named as SVC to use our support vector classifier. This function has parameter kernel. Here we have used linear kernel because we want to do the binary classification. This SVM classifier needs to be stored in some variable to apply some further functions on it. Therefore, here we have created variable named as CLF and stored our support vector machine classifier inside it. Now we need to train our support vector machine classifier using training data. For that, we have fit function under SVM package of Sklearn library. This fit function has two parameters. First parameter is xtrain, which refers to the features in our training data set. And second parameter is ytrain, which refers to output class labels of our training data set. We have trained our SVM classifier using fit function, and now our model is able to predict the class labels when we provide set of features for particular data record. And this can be done with the help of predict function, which is under SVM package of Sklearn library. The parameter passed to this predict function is x_test, because if you remember, while splitting our data into training and testing data, we have stored feature set of our testing data set under the variable named as x_test. And this predict function will predict output class label based on these features and store it inside variable named as ypred. So variable y_pred consists of output class labels predicted for testing dataset by our trained SVM classifier. But we already knew the actual class labels for this testing dataset, and those class labels were stored inside the variable named as y_test. Therefore, to check how many incorrect classifications are done by our trained SVM classifier, we need to compare the values of y_test and y_pred. And this can be done with the help of different performance metrics like accuracy, precision, and recall. All these performance metrics can be used with the help of metrics package of Sklearn library. This package provides function named as accuracy_score to calculate the accuracy. Parameters passed to this function are y_test, means actual class labels which were there in testing dataset, and y_pred means class labels predicted by our trained SVM classifier. Accuracy score returned by this function is 0.96, means around 4% records were classified incorrectly using SVM classifier. In the similar way, we can calculate precision and recall using precision_score and recall_score functions of metrics package. Thank you for watching.